manufacturing, right? So mold length, generally it is depending upon the molding machine, right? Okay, so here this is the molding machine. Okay, which is this area? Tell me, what is this area?
Mold cavity.
Clamping area.
Injection area.
Clamping or the tooling area, you can say that, right? Okay,
Yes.
where you have to where you have to put your tool in order to produce the component in mass production, right? So this is your mold tool here, right or wrong? And here your mold tool will be clamped. This is the
Clamping plate.
fixed plate. This is the moving platen, right? Understood?
Yes.
Okay, so this area is very important. So, if I am talking about the length and width, how to decide the length and width, so basically it is depending upon the component geometry. Though there is no specific formula for decide the length and width of the mold. Is it clear? Your component should be like can be like this. Your component can be like this. Your component can be like this, right? So there is no specific formula for decide the length or width. Is it clear? So basically it is depending on the manufacturing possibility, that how much you can say that possibility of the manufacturing, that how much type of cavity or the core we can create by the VMC or the CNC machining, right? And now see here, see, for example, mold size, as I told you, which is depending upon two things. First of all, tie bar distance of the injection molding machine, and second one is possible manufacturing. As I told you, what is the tie bar distance of the injection molding machine? Here, where is the tie bar? Tell me, in this machine. Right, this is the tie bar from where your mold will be. You have to put the mold from the, right or wrong, from this direction, right or wrong? So this is your tie bar. Tie bar will be like this. Understood or not?
Yes, sir.
Okay,
Yes,
so
sir.
you should have knowledge about the tie bar distance, about the horizontal and the vertical distance of the tie bar. So depending upon that, you can decide the maximum length and the width of the mold, length and the width of the mold, right?
Yes, sir.
So depending upon the tie bar, so on the tie bar we can decide the maximum length and width. Now if I am talking about the how to decide the minimum length or width of the mold, minimum length or the width of the mold, because we don't want to waste our material, right or wrong? Because metal or the material is the costly, right or wrong?
Yes, sir.
Metal has a few costs. For example, if I am talking about the MS, so what is the rate of the MS right now per hour per kg? What is the rate of
Between
MS?
80 to 120.
Sorry, again 180.
80 to 120.
80 rupees to 120, right? Okay, if I am talking about the P20 material, tell me, which is more hardened than the MS material?
MS.
Yes, so what is the rate for the P20 right now? You should say it is a costly right now, okay? Don't tell me the exact rate, okay? It will be vary depending upon the location. For example, if you are asking in Pune, if you are asking in Delhi, so it will be vary. Is it clear? The rate will be vary depending upon the location, right? Okay, so first of all, tie bar distance, and the second one is possible manufacturing. So depending upon that, these 2 points, we have to decide our mold length and width. See, tie bar distance. See, for example, this is the machine plate, and in the top view, you can say that, into the top view. Okay, so you should have knowledge about this distance here. See, you should have knowledge about this distance and like this distance. So why? What is the reason of that? Tell me, anyone? Why we should have this? Why we should have knowledge about this distance between the tie bar? For deciding the maximum length and the width, right? Okay. From where, which direction mold will become? In this direction, right? Mold, usually if I am talking about the mold weight, it is around more than 150 kg, right or wrong? We have to use the crane for lifting the mold, and we have to put the mold from this direction, right or wrong?
Yes, sir.
Right? Okay, so here this is the text here, so that's why I will use this direction, right? Right now I'm using this direction. For example, this is the top view, this is the top view, na? You can say that, right? So for example, mold will be like this. So this is the length and width, and mold will come like this. See here,
Okay.
see, right? It will become like, so it should be less than this distance. It should be less than this distance, you can say that, right? So this is very important. Understood?
Yes,
Okay,
sir.
so mold length and width should be less than tie bar distance. Okay,
Tie bar.
anyone, length or the width. So I'm mentioning this distance. Right now I'm mentioning this distance, right? Okay, understood?
Yes, sir.
Okay. Now, possible manufacturing. Acha, what is the meaning of possible manufacturing? For example, if you are creating a plate like this, okay, and you are trying to manufacturing two holes. For example, this is the one hole, and this is the another hole here. This is the another hole here. Okay. So if I am machining this two hole, it means there should be distance between two holes, right or wrong?
Yes.
For the proper manufacturing. So this is known as possible manufacturing, that your component or your plate will not fail in future, right?
Yes.
So that's why, so this area should be strong, this area should be strong between the two features or the two hole, you can say that, right? So this is known as possible manufacturing. Now here is, you can see that this is the mold I have. Okay, I am zooming some area. For example, I am zooming this area here. So here you can see that this is the red area here. Okay, or what is the red area here? What is this red area? This is nothing but this is the possible manufacturing. So this distance should be minimum 15 to 20 mm, which is the possible manufacturing. It is the meaning of that. From one feature to another feature, always a distance between 15 to 20 mm, which is the possible manufacturing. Right or wrong? Understood?
Yes, sir.
Now, for example, you have a component like this. For example, you have a component like this, right? Okay, and you are preparing a core and cavity. Okay, so here, for example, your core and cavity will be like this, right? And if I'm talking about that from this distance to from this point to this from this point to this point, what is the distance between these 2 points? For example, let's taking 20 mm. Is it clear?
Yes.
And the component length is around, for example, it is around 50 mm. Is it clear? Okay, so as I told you, this is the insert. As I told you that this is the insert here. Okay, so here I will take one more plate, which is the housing, which is the core plate and the cavity housing. Is it clear? For example, this is the, again, what is this? This is the plate, and in this plate I will prepare one more features. 1 minute, holes, you can say that. Hai, see here, this is the guide pillar, okay, or the guide bush. Is it clear?
Okay.
Okay, for example, again, this is nothing but this is the return pin, one more feature or one more element, you can say that. And this is nothing but, for example, this is the bolting, for example, for clamping the plates, hai na? For example, this is the bolting. Is it clear?
Okay.
Right? Hai na? So this is nothing but this is the just a top view. So you can see that, so there is a, from this point to this point, there should be a distance, right or wrong, which is the possible manufacturing. So right now understand that this is the length of the component. From this point to this point, this will be the 20 mm. Right now I'm seeing the vertically, and I'm watching the vertically. For example, again from this point to this point, again this is the 20 mm. Okay, again from this point to this point, this is again 20 mm, for example, right? Okay, and here diameter of this pin is around 15 mm, just for an example, right? So see what is the distance from this point to this point. See, 20 plus 15 plus 20, how much? 55, hai na? Again from this point to this time, this will be the 55 again, because this is the replica, here,
Definitely.
right? Now you can see that 20 mm plus 20 mm plus 50 mm. What is the distance?
90.
90. 90. Add all this distance. See.
200.
Okay. So this is nothing but this is the length. This is the minimum length which we have to apply for the length of the mold. This is the nothing but this is the possible manufacturing, right or wrong? So
Yes.
there is no requirement, for example, if the tie bar distance is around 320 to 270, that we have to prepare the our length around 270. This is not the necessary, but possible manufacturing means how much minimum length or the width you can take, but depending upon the manufacturing feasibility. Understood? I hope you understood about this.
Yes,
This
understood.
is very important, right? So basically possible manufacturing of the mold. Why? Because minimum distance should be 15 to 20 mm from one feature to another feature. For example, like I am creating a two hole, so between the two hole there should be a thickness, you can say that, right? So this red area should be strong. This red area should be strong. Understood? So this is very important concept, which is the manufacturing possibility. So there is no specific formula for that, as I told you, depending upon the component geometry, right?
Correct.
Right? Okay. Now again, depending upon the costing, okay. So for controlling mold cost, we should choose the manual method for decide the length and width. Okay. Acha, what is the why I'm telling the manual method? Why I'm telling the manual method word? Because in the industry there is a standard also available, right? Like HASCO standard. You know about the HASCO? HASCO, DME, Furacia. This is the standards available, right? But if we are using this standard or the length or width, our mold cost will be high. Because for why? Acha, what is the reason of that? As I told you, in the manual method, we are preparing the mold length and width depending upon the component size, right or wrong?
Yes.
But what happened here in ESCO standard or the DME or the Furacia standard? We just mention that this is our component, or we just select the mold size, and here this is the standard size. For example, 250 to 250, like 300 to 300. Like for example, like, so we have to choose one of the size depending upon the component, right? And you can say that if we are choosing the standards, so there will be the unwanted elements which will be come with the standard, right or wrong?
Correct.
Which is not required. So that's why manual method is important for controlling the costing, right?
Yes.
Okay. Now see, manual method is used for save the overall mold costing, and the standard HASCO method or the DME or the Furacia, any type of method if we are choosing for the mold base, which is providing the mold dimension or the mold base dimension, we can say that. So by which we can get the reliability, you can say that we can get the reliability, but costing will be high. Is it clear?
Yes, sir.
But if we are choosing manual method with the complete calculation, though it will be more reliable than this, right? It will be more reliable than this. Is it clear? So that's why always we should go for the manual method, because depending upon the component geometry, for every component we cannot use this standard method. We cannot use this standard method depending upon the complex geometry. Is it clear?
Yes, sir. Yes.
Okay,
Yes.
so that's why manual method is very important. Is it clear? Okay. So here, calculation for two cavity mold. Here I am showing you a data for the 80-ton machine, right? For example, I have a component like this. I have a component depending upon the component. You can say that depending on manufacturing feasibility, right? So here, here you can see that we get the data of 80-ton machine from the catalog, right? So here this is the tie bar distance, which is the 355 or multiply by 300. Is it clear? This is the short capacity.
Capacity.
This is the short capacity. Or what is the meaning of short capacity? Again, tell me. Tell me. Short capacity meaning What is the
Material to material will.
how much material we can feed into the impression in one shot? This is known as shot capacity, right? Which is the very basic of the injection molding machine. In first and second lecture, I have told you, right? Okay. Okay. So tie bar distance. This is the maximum length or width we can decide, right? Shot capacity is nothing but it is related to the component weight. Component weight, right? Minimum and the molding, minimum mold height or the maximum mold height we will get from the catalog and the ejector stroke, which is 80 mm. What is the meaning of that? That your component height should not be more than 70 mm, right? Because we want to eject the component in a proper way from the mold, right? That's why. Is it clear?
Yes.
Okay. So here this is the design, you can say that, okay, in which we have to take you can say that, for example, this is the design of our mold, for example, right? Okay, so we are deciding this length. Okay, so this length or this you can say that this distance from this point to this point, consider, for example, this is the width. Okay, now for example, depending upon the 80-10 machine, if we required for this two cavity component, we required 80-10 machine. So what is the meaning of that? It should be for example, this distance from this point to this point, it should be less than 300,
300.
right? For example, less than 300, because this is the length, this is the width. Is it clear? It should be less than 300, right? So from this point to this point, it should be around, for example, 280, just for an example. Is it clear? This is nothing but this is the possible manufacturing, depending upon the possible manufacturing, but we have to consider this tie bar distance also, because this is providing the how much maximum length or width we can decide for our mold. Is it clear?
Yes.
Understood? This is about the how to decide the mold length and width. Or during the designing, we will learn more about that. Okay. During the design, we will understand about that also. Okay. Now, second thing is how to decide the height. How to decide the height. Okay. See. How to decide the height. Now see. Again. Acha, what is the meaning of height as I told you? How to decide mold height. Okay. 1 minute.
It depends on the shot. Sorry, there's some
Of
part.
course. Depending upon the from the catalog, we get some information about the minimum mold height and the maximum mold height, right? So we have a criteria there. We have a criteria. We have a limit that maximum mold height should be this, but minimum mold height should be this, right? So, but if we get the for example, if we get the length or the height in mid of this range, so which value we can select, right? So which we will learn in this lecture, right? So this, for example, as I told you about the shut height. Okay, what is the meaning of shut height? Like for example, this is a fixed half, right? Which is the combination of top plate and cavity plate, and or this is the moving half, which is the combination of core plate, bake plate, spacer, bottom, ejector plate or ejector back plate. Is it clear? So as I told you that mold height is nothing but it is the mold height. What is the meaning of mold height? In closed condition, not in open condition. In closed condition. Is it clear? Because in closed condition we have to put the mold into the injection molding machine, right or wrong?
Yes, sir.
Into the closed condition we have to put the mold into the injection molding machine, right? So that's why this is nothing but mold height or the shut height, you can say that it will be in closed condition, right? It will be in closed condition. Now see, mold shut height, generally it is depending upon, its limit is depend upon the molding machine first of all. Okay, molding machine, and second thing is cooling channels. Cooling channel, then how much diameter of cooling channel we are deciding. Okay, depending upon that. Is it clear?
Yes, sir.
है ना? चलो. See here, for example, as I told you, mold height is depending upon the cooling channel diameter and the injection molding machine open and close limit. But as I told you, that catalog gives a few information about that. That what is the mold minimum height and mold maximum height, right? So basically from the catalog we get this information, right? Right. But here we have to see this point, which is about the cooling channel diameter, right? Cooling channel diameter. Now see here. For example, depending upon the cooling channel diameter, I am deciding the core and cavity thickness right now. See here, for example, right? Okay. So first, just for an idea, right now I am telling you about the how to decide the cooling pipes. है ना? Cooling pipe channel, you can say that how to decide the cooling diameter. Is it clear? Just for your idea. For example, cooling channel or the cooling diameter, है ना, which we have to provide to the core and cavity in order to cool the component. Is it clear? Okay, so basically diameter of that cooling channel is depending upon the wall thickness of the component. For example, if the wall thickness of the component is about 0 to 2 mm, okay, so we can take the diameter about 4 to 8 mm. 4 to 8 mm, है ना? If the wall thickness is about 2 to 4 mm, 4 mm, right? So we can take the 8 to 12 mm, 8 to 12 mm. Is it clear? If the diameter is from 4 to 6 mm, then we can go for that 12 to 20 mm. Is it clear or not? Tell me. Is it clear? Just for your idea, depending upon the wall thickness, we have to decide the cooling channels. Is it clear? Understood?
Yes.
Just for example, I am telling you one thing, that for example, if your component wall thickness is 0.5 to 1 mm, right? So what diameter you will decide? Tell me.
Between 48.
4 to 8, yeah. So how much we can take? For example, tell me.
I'll take around 4.5.
4?
Like
Okay.
that.
For example, you are taking the 4 mm. Right?
Yeah.
Acha. In your finger, just imagine that what is the length of the 4 mm. Tell me.
Sorry, I didn't get you.
In your finger, for example, if I'm talking about your nail thickness, so what is your nail thickness? Tell me.
It may be less
0,
than 1 mm.
0.5 mm. You can say that, right?
Yeah.
Okay. So what is the thickness of the 4 mm? It is around. If I'm draw in whiteboard, so it will be like this.
Yeah.
Okay.
Yes.
So 4 mm is very less diameter. You can say that. Okay. So for preparing the 4 mm diameter cooling pipe, we have to take the drill of the 4 mm or less than 4 mm, right or wrong? Okay. And what is our mold size? Mold size is about 250 multiplied by 250, for example, just for an example. So we have to drill the 4 mm size from this point to this point. Is it possible?
It is very difficult.
It is very difficult. So you can say that this is not the feasible for the manufacturing.
Yes.
Na? If I'm talking about machining in India, for example, if I'm preparing a mold with 4 mm cooling line, so it is very difficult. It is very difficult, right? So instead of the 4 mm, customer always suggests that, sir, we should take 8 mm minimum, because we cannot prepare the 4 mm or the 6 mm cooling pipe, right? So we can prepare the 8 mm cooling pipe. Is it clear?
Yes.
Okay, so that's why if your wall thickness from 0 to, for example, like 0.5 to 2 mm, so you have to select 8 mm or the 10 mm for the manufacturing feasibility. For the manufacturing,
Yes.
that it should be feasible for the manufacturing, right?
Yes.
Okay, so this is very important. This is very important. Is it clear? So right now, depending upon the cooling channel, I am deciding the core and the cavity thickness calculation. Is it clear? See here. For example, I have a component like this. Okay, or for example, I have a component, so here I have to use the cooling pipe. So here from the cooling channel to this face, there should be distance. How much? Tell me. Tell me about the depending upon the possible manufacturing.
15 to 20.
है ना? 15 mm I can take, right or wrong? Okay, just right now, just suggest. For example, I have a cooling pipe, and the diameter is about to 8 mm here. Is it clear? What is the diameter? 8 mm diameter. Okay. So for the manufacturing feasibility, I will take the 2 into A. And from, well, say from the center, is it clear? From the center to this face, and again from the center to this outer face, I will take the 2 into A. And what is the A here? A is nothing but A is the 8 mm.
Wait.
Okay, so 2 into A will be the 16 mm. Here 2 will be the 2 into the A. What will be the 16 mm? Is it clear?
Yes.
Okay, so you can see that just for an example, right? So this will be the component height, which will be the H.
Yes.
Okay, so we can decide the core or the cavity thickness, right?
Yes.
And
Yes,
just for
yes,
an
yes.
idea, I'm telling you this, right? Just for an idea, I'm showing you this. Okay, just for an example. Acha, for example, if I'm purchasing a material, so what is the nominal size for the material, for the raw material? Tell me. For example, 100, right? And it will be around 50 mm. Like for example, 75 mm, right? And what will be the thickness? It is around, you can say that 30 mm, maybe 50 mm, like 75 mm, like it will be 100 mm. So you will not get thickness like for example like 37, like 38 or 41. You will not get this thickness, right or wrong? What thickness you will get? You will get in round figure. Okay, so basically why I am telling you this point, because we want to save the manufacturing also. We don't want to extra work, right? If we have a thickness already in raw material, so why will go for the machining, right? Right? Okay, so for example, if the component height is about 20 mm, and this will be the 16, so what we should have take? Tell me. This will be the 32 plus 50. So basically I will take here 50 mm. I will not take the 52, right?
Yes.
Understood?
Yes, sir. Yes, sir.
Got it? This is very important thing. Is it clear? Okay, basically we are a designer. If we are designing any mold tool, so basically it should be less costly for the manufacturing purpose, right? For the customer. Is it clear? This is very important. Understood? So right now I am taking the cooling pipe, for example, cooling pipe here. Okay, and the cooling channel diameter is about 2A as I told you. So from this point to this point, this will be the distance from center to this space. It will be the 2A, and from this point to this point will be the 2A, right or wrong? Again, from one channel to another channel, there is a distance about 2 into A. Why? Because this distance should be, or this area should be strong, right or wrong? This area should be strong, right or wrong?
Yes.
That's why. Okay. Again, from this point to this point, this will be the 2A. Now, this is the component height H. Okay, now take the cavity thickness. What will be the cavity? 2A plus 2A plus H. This is the thickness. Right. Again, core thickness will be the 2A plus 2A.
Plus 2A.
In close condition as I told you.